Start with 2 retirees, same portfolio, $1 million, same annual withdrawal, $50,000, and the same 10 annual returns, just in the opposite order. The average return is the same, 5.8%. But after 10 years, one path ends around $594,000. The other ends around $1.15 million. Same money, same withdrawals, same returns, a $558,000 gap. The missing variable is not the average return. It is the order. The reason this feels strange is that most investing math starts with accumulation. If no cash leaves the account, returns mostly act like multipliers. A gain, then a loss, is the same final product as the loss, then the gain. In symbols, ending wealth is starting wealth times the product of all gross returns. That product does not care which identical return block came first. In our example, with no withdrawals, both orders finish at the same value, about $1.566 million. So the average return intuition is not foolish. It is incomplete. Retirement adds one operation that accumulation did not have: subtraction. Each year, the portfolio moves with the market, and then spending comes out. The state after 1 year becomes the starting point for the next year. That is why the formula is no longer one clean product. It is a recurrence. The withdrawal is the same dollar amount, but it hits a different-sized portfolio depending on what happened before. This is the hidden state variable: current wealth. Once current wealth is damaged early, future good returns compound on less capital. Another way to see it is to stop looking at dollars and look at units. If prices are high, a withdrawal sells fewer units. If prices fall first, the same cash withdrawal sells more units. Those units are gone when the recovery finally arrives. The danger is not just losing money. It is losing the engine that future returns would have compounded. That is the mechanical heart of sequence risk. This is why the classic retirement studies were not asking, what was the average return? They were asking, if someone retired in this exact year, did the portfolio survive the next 30 years? William Bengen's 1994 paper found that an initial withdrawal rate around 4.15% had survived the historical cases he tested. The famous shortcut became the 4% rule, but the deeper idea was the sequence test behind it. Bengen identified late October 1968 as a particularly severe starting point because the retiree faced bear markets and inflation early in the path. The Trinity-style work by Cooley, Hubbard, and Walls tested withdrawal rates from 3% to 12% across horizons including 15, 20, 25, and 30 years. That is the key. These studies are not promises. They are historical survival maps. But one number can hide the moving parts. Raise the withdrawal rate, and the failure boundary moves closer. Increase volatility, and the same average return becomes less reliable. Add inflation-adjusted spending, and the cash withdrawals can grow while the portfolio is trying to recover. Add flexible spending, and the boundary can move back because the withdrawal is no longer fixed. This is not a magic formula. It is a stress test of a path. The wrong takeaway is that one historical number is safe for everyone. The wrong takeaway is also that early losses automatically ruin retirement. Taxes, fees, asset allocation, inflation, pensions, and spending flexibility can all change the result. But none of those removes the core mechanism. Withdrawals make return order matter. That is why this is education, not a prescription. In accumulation, the main question is, what return can the portfolio earn over time? In retirement, the better question is, what path can the portfolio survive while cash is leaving? The first question is about expected growth. The second is about sequence, spending, inflation, and time. That is the difference between a portfolio that compounds and a portfolio that must also pay bills. So average return is useful. It is just not enough. In retirement, the market does not only ask what you earned. It asks when you earned it. Average return is a statistic. Retirement is a path.